It's recording now. Thank you. Okay, suppose that we have a function notation, y equal f of x. But on this function, I want to do transformation. The first transformation is y equal fx plus something. A represents a number. It's a constant, no? When this situation happens, well, the transformation is you have a point on the curve x comma y, and the transformation is x stays the same, and y no. Y is adding plus something. So basically, this is typical vertical shift. Vertical shift. And this vertical shift is, suppose that A is positive, then the transformation is going up. Okay, it's going up. See, A is negative, it's going down. Okay, after a problem, you see animation, you see clear. But basically, vertical shift motion is no deformation, no zoom in, no zoom out. No. It's only move. And what direction? One of the direction that you are in. For example, do you understand this? Suppose the function y equal x squared. Okay, this is my basic function. I call that. And the transformation I generate from this, suppose, is y equal x squared plus 2, or plus 3, or plus 5, or plus whatever, any number. In this case, the graphic of this and the graphic of this is similar, but the transformation is moving 2 units up. Si es negative, well, you're moving, to, suppose minus 5. In this case, up, in this case, is down. That idea is clear? Everyone follow me? Do you understand the idea or no?
Yes.
Okay, this is straightforward. This is super easy. Another no, but this is easy. Suppose the second one. The second is y equal I introduce the number, but not outside the parenthesis, no, inside the parenthesis, x plus b. And this is horizontal shift. Horizontal shift. Es similar idea. But the horizontal. Why a horizontal? Well, because the operation that you are doing is on the x, not on the y. So in this case, x minus b. Entonces es really weird que si you add in plus and the point is subtraction, it's the opposite direction. Always when you make operation inside the parentheses, it's opposite. And y stays the same. That actually the motion is horizontal because you change the x component and the y no, y stays the same. However, you analyze when the b is positive and when the b is negative. When the b is positive, the motion is to the left because it's subtraction. And when the b is negative, it's to the right. So in conclusion, suppose again, we come back to the y equal x squared. This is the classical example. However, I do the transformation in this way. Suppose x plus 2 squared. Do you see it's different to this? This was 2 outside the parenthesis. That means you affect the y component. In this case, no, it's inside the parenthesis and you affect the x component. In this case, the motion is to the left. You see in the animation after. And here, no. Here, suppose it's x minus 3 or minus 5 again. Square is to the right. You need to know, so in order to make easy the analysis, if you will be able to memorize, okay, when the x, when the number that you add in here, b, is positive, the shift is to the left. Si es negative, it's to the right. Entonces es relatively easy to solve the problem of this part. So you will be able to memorize this. Okay, this is shift. Shift is motion, no deformation, no compressing, no stretching, only motion. Okay. Now the next transformation is when you, for example, multiply the function by one number. Entonces in this case is you have a point and the transformation is the x stay the same, but the y no, the y is multiplied by the specific number, no? And this is, well, this is more complicated because there's no motion, it's deformation. So we have three kinds of deformation. We have a stretch, we have maybe compress, or we have reflection. That depending of the number que you multiply and the sign of the number que you multiply. Suppose que A no, sí, sorry, es greater than 1. Entonces es stretch. Ok, es stretch, pero vertical stretch, ¿no? Vertical. It's vertical because, okay. Suppose y equal x squared. This is my original function. Now I multiply by 2x squared. So suppose que when you multiply by 2 or by 3 or one number greater than 1, the parabola, que normally is like that, this is my original parabola, is a stretch, vertical stretch. Vertical stretch is like that. A little bit narrow, okay? Because you multiply any number by 2. And so you multiply basically the y part and the x part stays the same. However, si c is less than 1, entonces compress. Entonces, like a horizontal compress. Horizontal, no, sorry, vertical. This is vertical. This is vertical because the action is on the y-axis. Vertical, stretch, compress, or reflection. Okay, and is C es negative, specifica -1. Bueno, si es -2, entonces es combination, pero si es -1, es no stretch, no compress, pero es reflection, pure reflection. Entonces, suppose que es y equal -1, entonces negative x squared. My parabola look like that. Look, let me show you. This is minus x squared. This is like a reflection que represent the symmetry, no? About the x-axis. Okay. We have one more transformation, and after we see example, and you understand much better this. This is theoretical part. Okay, now suppose the last transformation is y equal f of n dx. So now multiplication again, but no outside. No outside. It's multiplication inside the parenthesis. And always can happen inside the parenthesis. The operation is completely inverse operation. You remember that in the horizontal shift, when you adding plus one number, is actually subtraction. In this case, multiplication, entonces es division, que es the inverse operation. O sea, when the transformation is inside the parenthesis, is completely opposite operation. And the action, again, is horizontal. It's horizontal because the transformation we are doing on the x component is horizontal. But horizontal maybe stretch again. Or reflection, no? Or reflection. Entonces, if, for example, if D is the number is greater than 1, is completely opposite to this. This is a stretch, now it's compressed. Si D is less than 1, it's a stretch. And si D is equal to -1, is reflection. But remember, this reflection is with respect x-axis, and this is reflection with respect y-axis. It's the only difference. Okay. Or for example, let me try to understand using a square root function. The square root function, you know, is square root function, no? Like that. A square root function look like that. The graph. And when you make a reflection, suppose I make this reflection, I replace x for negative x. The new graph look like that. Okay, reflecting this red graph is square root negative x equal y. Okay, and this is the big picture about transformation. Let's see example now. I propose first of all, before the example, see the animation to understand much better this. And after, let's move on to the example. Okay, let me try to find the okay, super. The Desmos, switching to Desmos. This one. Do you see Desmos? Do you see Desmos?
Yes.
Okay. So I activate, look, okay, in red color, the parabola, because parabola is super easy function can help me to understand this. But sometimes some transformation is not clear seeing the parabola, but the most important thing. Okay, so we have different slides here. I can change A, B, C. For example, let's come back at the beginning. Vertical shift. Vertical shift is plus A. Here, plus A. Let me activate this. Okay, so we have two colors. We have red color for the original, and we have the black color for the new one after the transformation. No? And you see that they are perfect coincidence because every parameter is A or 1. However, if you apply A equals something positive number, look at what happened. This is what the name of this transformation is vertical shift. In what direction? Upward, because A is positive. Si A is negative, downward. No problem. Do you understand very well this?
Yes.
Sure. Okay. Now B. Restore 0. No transformation. B. Bueno, B. Same parabola, but I change B. See, B is positive. The motion is to the left. Do you see? And see, B is negative is completely to the right. It's completely opposite operation because the transformation you are doing inside the parenthesis of the function notation. So when this situation happens, it's opposite. Plus is subtraction. Negative is addition. Okay. Do you see? What is the name of this transformation? Well, the name is horizontal shift. To the right or to the left. When it's negative, to the right. When it's positive, it's to the left. Everyone follow me? Everyone follow me?
Yes.
Super. Okay, now let's see the stretchy compression. The stretchy compression is different because the action is deformation or reflecting the curve. So for example, suppose C, I change C to positive value. Look, do you see how the parabola is now a little bit narrow because the y increasing, increasing and the x stays the same. So you compare two couple of points, for example, this point and this point, you see for the same value of the x, approximately, the y increasing according to this coefficients. Suppose now that the coefficient is less than 1. This is 1 less than 1. Whoa, less than 1. 0.3, 0.2, 0.1. Entonces you see que now our new parabola is wider because you to compare, select 1 point here. Okay, you have 1x value and the y is 1 point something, and here the same value of the x have, of course, greater value of this. Okay, this is the original. Remember, the original is the red, and the black one is the new one after the transformation. And if you put here like a -1, look, negative number, -1, -1 is perfect reflection. Look, perfect reflection. This parabola is completely symmetric with respect to the x-axis. So you have no negative ones, you have a number, -2, negative something. Entonces you see the combination of the stretch and reflection. Here, less than 1 is the combination compress horizontal. Horizontal, no, vertical, sorry. Vertical compress and reflection. Okay? Do you see that? Si es 1, si es 1, si the factor is 1, entonces no transformation. No transformation. Everyone follow me so far? So we discussing vertical, stretch, compress, and reflecting or reflection. Who has the microphone on? Christy. Christy? Thank you. Okay, no problem. I understand. Now let's move on to the D. O sea que es horizontal, stretch, compress, or reflecting. Change D. Pero D, well, it's not clear. O sea, I propose change the function. No parabola anymore. No parabola. Let's move on to the square root function. Because in the square root function is more clear to see the effect. In my opinion, no? Entonces now, the new one after the transformation is this. There are perfect coincidence between red color and green color because no transformation, no? Entonces let's move in D. Si D is positive. Okay, entonces this is not too clear, the transformation, but I want to explain. Actually, is horizontal transformation because it's inside the parenthesis, D. But this is like a horizontal compress because you compare, for example, 1 point here and the same point here, you see how moving a little bit compressed. So it's like it's somebody, so the interpretation is like it's somebody pushing the curve to the left. Entonces this is horizontal compress. However, if D is less than 1, in my opinion, it's clear to see that. Look, 0.7, 0.4 is horizontal stretch. Look, compare this point, for example, in the same line, this point is a stretch. And if D is negative, specifically -1, is a perfect reflection with respect to the y-axis. Well, see, you have another number that is different to the -1, for example, negative something. So we have a combination. In this case, you have reflection and horizontal compress. See, the number is in between 0 and -1, suppose -0.5, for example, is reflection, but is also stretch. Stretch and reflection, the combination. Okay, let me restore this. Let me restore this. Do you understand or not? Let's move on to the example now. So today is the day for the transformation. Go ahead.
Sorry, but when it goes on to stretch again, confused.
Okay. This is when the D is less than 1. Here, over there. Horizontal stretch. Horizontal stretch, yes. The thing is that you need to analyze horizontally, like that. 1 point here and 1 point here. Okay. Actually, si bueno, professor, I saw que es vertical, like that. Vertical compress. No. No, why no? Because the analysis is in this direction, because the transformation you are doing on the x-axis, in the x component, not in the y component. Y component stays the same. So you analyze this. Y component stays the same. It stays the same. Sorry, it stays the same. It's like that. It stays the same. Here, and another analog point here. And the transformation is horizontal stretch. Yes, stretch. And when the D is greater than 1, like 2, like 3, entonces now the analysis is compressed. This is 1 point here, another point here. Okay, horizontal in this case was compressed. This is relative. You need to understand the nomenclature of the definition, no, of the thing. I use the same definition of the book, no? You say, well, we need to call one name. The action we can interpret in different way. However, no. I need to make a decision to interpret it in one way, exactly like our book. And to say this is obviously the action is horizontal, and this example is compressed. And this example now is stretch. Do you see it now more clear, Miss?
Yes.
Yes.
Excellent. Okay, let me restore to 1. Okay, let's go back again to the whiteboard. In the whiteboard, I want to explain the example. Again, we transfer with the decimal, no? Okay. And now switching to whiteboard. Yeah. There you go. Do you see the whiteboard again or no? Yes or no?
Yes.
Yes. Okay, let's move on to the first example. Example 1. Okay. Example 1. Well, in the example 1, we have this. F of x is equal square root x plus 6 minus 5. Entonces, I realize que this function belongs to the family of the function square root x. This is the basic function. Okay, we start for this. However, you analyze one by one the transformation. You analyze according to the order of operations. The first operation I can see is this. Okay, because when you plug in one number in the x, the first operation you should do is addition 6, no? Entonces this is, suppose que yo isolate this. This is square root x plus 6. This is like a horizontal shift, 6 units to the left. How do you know it's left? Because it's positive. See it's negative right. See it's positive left. And finally, this minus 5 outside is vertical shift. It's vertical shift, 5 units down. And that's it. Do you see that?
Yes.
Pero yo think I want to see in decimals. I want to see in decimals. So let me try to find decimals. And Desmos, okay, I have here, okay, transformation, example of transformation. Okay, good. Okay, let me try to share the new screen. Switching Desmos. Okay. Do you see Desmos again?
Yes.
Yes.
This is the example one. Look, in the example one, the function that we have is, okay, step by step. The original function, okay, I want to graph it is this. And this is how you get that. When you start at the beginning, but the square root function is this. Okay, the first transformation was this. What is the name of this transformation? Well, it's horizontal shift 6 units to the left. And finally, vertical shift 5 units down. Boom. So the final answer actually is the green color. The rest was auxiliary construction to help me to get the final answer. Do you understand this or no?
Yes.
Yes.
Absolutely. Okay, super good. So let's continue in this one. In order to don't try to switch again to one more. The next example is this one. Okay. Is you copy y equal minus parenthesis x minus 5 squared plus 3. Okay, so I realize que this function que es given, que the professor want que you do the graph is belong to the family of the parabola. This is the original parabola. So the first transformation that I can see is is horizontal shift here minus 5, horizontal shift 5 units to the right, no? Remember, negative right. Boom. This is my new one. The second is a negative 1, okay, put it here, okay, have the original expression, of course, a reflection. But what kind? Well, a reflection with respect the x-axis, because it's outside the parenthesis, no? It's the blue. Reflection, I did that. And finally, plus 3, and plus 3 is vertical shift 3 units up, because it's positive. Boom. And this is the final answer. This is the final answer. After the 3 transformation in this case. Let me recap again. Original horizontal shift 5 units to the right. Reflection with respect the x-axis because it's outside, no? Vertical shift 3 units up. Do you see that or no? Confusing or clear?
Clear.
Okay, super. Okay, this is example 2. Let's move example 3. Example 3 is similar. It's cubic function. So this is expression is given, this one. Do the graph of this function using transformation, and we start from the original basic function. By the way, the last class I sent to you, if you want, I send again, one document in Word que is about the collection of the most important function que we are working in this subject, no? Entonces, you have the equation, the name, domain, range, and the typical graph. So it's important que you somehow be familiar with this function because it's a function that we are using, no? What is the function? Well, linear function, parabola, que es square function, cubic function, square root function, and so on, absolute values, and so on. So we start for the cubic function, que look like that. This is the cubic function. Entonces I see my original que is this, two transformation. The first one is -1. -1 is horizontal shift, but in this case to the right, because it's negative. Okay, entonces the blue was the transformation horizontal shift 1 unit to the right, because it's negative. Finally, +7. +7 is vertical shift. Remember, when it's outside the parenthesis, it's vertical. When it's inside the parenthesis, it's horizontal. 7 unit up. Okay, so my final answer is this. Okay, repetition. Start for the original cubic function, because I identify that our original example belong to the family of the cubic function, no? Okay, entonces I saw que we have first transformation que horizontal shift 1 unit to the right, because it's negative. And finally, vertical shift 7 unit up. Bam, bam, bam. This is the final answer. Okay. Let me explain now number 4 and number 5 example. It's a little bit weird. So I propose you come back to the whiteboard because I need to explain something. Okay, so now we come back to the whiteboard. Okay, switching to whiteboard. Okay, there you go. Okay. Here, do you see whiteboard? Let me recap. Yeah. Now let me recap. Example 2 was f of x equal minus x minus 5 square plus 3, ¿no? Entonces I see, wow. You start for the basic function. What function I select? 1x squared. Because this function belongs to this family, no? Square. Okay, now the first transformation according to the order of operation is this. Entonces f of x is equal x minus 5 squared. This is horizontal shift 5 units to the left, to the right, sorry. A right because it's negative. What is the next? Well, the next is reflection, because you see a negative here. It's important that you understand very well. Okay, for example, we have two reflections. The reflection when you put a negative outside, and the reflection when you put the negative inside. Okay, this is reflection with respect to the x-axis, and it's a reflection with respect to the y-axis. Okay, so this is reflection. Okay, super. Reflection with respect x-axis, because the negative is outside the parenthesis. Okay, and finally f of x equal minus x minus 5 squared plus 3. Oh, this is vertical shift 3 unit upward. Make sense or no?
Yes.
Example 3, que we see in the animation, was f of x equal x minus 1 cubic plus 7. So we start for our basic function, okay, in this case is x cubic. This is our basic function. So I need to know a little bit que look like that. This is y equal x cubic. My recommendation always in the test, you using decimals always, okay? And when you in the test on paper, you can send me the graphic because in decimals you can export the graph like the image, and you send me attached with the answer of the test. So don't do by hand. By hand is horrible. You don't see very well. Now, what's the first transformation? Well, the first transformation obviously is this. According to the order of operation, no, is x minus 1. Well, f of x, let me put f of x. Another is x minus 1 cubic. This is a horizontal shift, 1 unit to the right. Super. And finally, x minus 1 cubic plus 7. Ooh, this is a vertical shift, 7 unit over. I want to discuss it now. Everyone follow me so far, right?
Yes.
No big deal, no big deal. Okay, let's move on to example 4, okay? It's a little bit confusing. Why? Because the example that we are doing so far, identification of the transformation was very straightforward, was easy, it's a totally explicit. However, not always happen that situation. Suppose f of x is equal square root 5 minus 6. So it's very confusing. This is a typical example in which you don't see clear the transformation because you see one of the professor, wait a second. I saw negative x, so I believe that we have reflection, no? Maybe here, but 5, I don't know, one of these horizontal shift, but I don't know if it's to the right or to the left. When you say that when it's positive is to the left, but when it's negative to the right. Okay, so you need, and this is a typical example in which you need to apply some algebra to understand a little bit the transformation. So not always is clear, not always 100% clear. Okay, you identify. You need to do something. So the something you should do is, look, you factorization, -1 here, and we have x minus 5. Let me check it out, see this and these are equivalent or no. You distribute here, it's minus x plus 5. Okay, here I arrange in this order x minus 5. This is equivalent. But now, in my opinion, it's easier to see the transformation. So the transformation is, the first transformation I can see is this. Look, suppose f of x is equal square root negative something. Negative x. This is a reflection. Reflection about y-axis. So I know that my original basic function is f of x equals square root x. Entonces I have some idea que look like that. Like that. This is the square root. So we are doing reflection. Reflection is like that. In that direction. A perfect reflection. Okay, now after I can see, so I did that part, x minus 5. And x minus 5 is obvious que es horizontal shift, 5 units to the right. Because when I know that when they're negative, it's to the right. Okay, do you understand a little bit or no? So not always is the expression is ready to see clear the transformation. So you need to manipulate. This is my first example. I promise I bring another example, no? In which you need to manipulate in order to understand more clear. Let's come back again to Desmos to see clear this example now. Okay, let me try to do my best. Desmos. There you go. Do you see Desmos?
Yes.
This is example 3. Now example 4. Look at the example 4. On example 4, okay, this is the original. It's given like that. Look, boom. Oh no. Oh no. Boom. This is the final answer, the graphic I want to get. But oh no, it's confusing. I don't understand very well. But let's do it step by step. Look, the first step is the basic square root function. Now, when I manipulate algebraically here, I see one negative here can represent this a reflection. Boom! Look at that. This is perfect reflection with respect to the y-axis. And finally, is x minus phi can represent the horizontal shift phi unit to the right. Look, in green color. And this is equivalent 100% to the original gets given. Look at that. In blue color. Look. Blue color, green color. Blue color, green color. Blue, green. It's equivalent. Do you see now? That the thing I try to illustrate can not always you are ready to see immediately the transformation. You need to manipulate, and this is the classical example when you have a square root and you have negative inside. So you need to factorization -1 outside. And now it's clear to see, no? Let me see, switching to whiteboard again. Okay. Do you see whiteboard?
Yes.
Okay. Let's move on. Do you understand this example or no? So the thing I try to explain is not always when you have equation, you can apply directly the transformation. No, you need to manipulate a little bit algebraically, no? Let's see example 5. And example 5 is another example that you cannot apply directly the transformation. You need to manipulate a little bit before it's ready. Suppose f of x equal x squared minus 4x plus 5. I suppose que it's a parabola, no? I suppose que belong to the family of parabola, no? Pero for me it's not clear what transformation I apply, no? In looking this expression is not clear. No. Okay, entonces I propose some algebra to manipulate it. What is the algebra? Well, not complete the square. Completed the square. Completed the square. Completed the square. Exactly the same method that we are using for solving quadratic equation. Complete the squares. Sometimes we need to apply in the transformation. Look, let me show you. I copy again. X squared minus 4x plus 5. Hey, why not? You break it down, this 5. Oh, no. Yeah, okay. X squared minus 4x plus the magic number que complete the square plus 5. Plus or minus the magic number que complete the square, because the intention is introduce artificially one number que complete the square. Pero si you introduce this in our function, affect the function, no? It's not equal to the original. And remember the formula is b divided by 2 squared. It's the same formula that we use. be a 4 in our example. I don't care the sign. The 4 divided by 2 is 2, square is 4. It's obvious que es 4. The magic number que you introduce here is 4. In order to doesn't affect my equation, you're subtracting 4. But now it's ready to factorization. The factorization of this trinomial is x minus 2 squared and 5 minus 4 is 1. Oh, wow. This new function is equivalent 100% to the original. This is the same as this. However, I can see clear now what is the transformation. The transformation according to the order of operation is this first, que represent a horizontal shift 2 units to the right, no? To the right because it's negative. And finally, x minus 2 squared plus 1 is a vertical shift 1 unit up. Boom! End of story. Let's see in the decimals to understand much better the idea. So the thing I try to convey, guys, is not always the expression gets given in the test is ready to apply transformation. You need to manipulate a little bit algebraically. Okay. Let me try to show you the last example. And this must look. Okay, go. Do you see Desmos?
Yes.
Okay, we are talking about the example 5. Okay, the example 5 is this. Look, actually this is belong to the same folder. This is this parabola. Look, oh no. How you get that? Well, we start at the beginning for the original basic parabola. Boom. After the completed square, I realize that we have the first transformation is horizontal shift 2 units to the right. Boom, blue color. And after that, plus 1. Plus 1 is vertical shift 1 unit upward. Blue color also. Let me change the color. Orange, maybe. Okay. Entonces I suppose que the orange curve is equivalent, exactly the same of the original. Let me show you. Oh, black, orange, black is equivalent. Do you see? Wow, amazing. I like that. Any question, guys? Super clear or super confusing? Okay, let me try. Clear, right? Okay, good. I like that. Okay, I bring here one conclusion. Let me try to explain the conclusion. Okay, no, forget about one. Okay, expand it. Okay, look. We have one function. Bueno, es the hypothetical function, ¿no? Es the hypothetical function, que es the function. Let me delete that part. Okay. I try, guys, to summarize quickly the information we discussed before, no? The transformation. Suppose that we have this segment, que es linear function, pero es defined in one specific interval in between 2 and 4. And I apply transformation. It's actually a function because when you apply the famous vertical line test, pass the test, no? Entonces, suppose. Bueno, okay. This is This is okay. Suppose this case. I call the function b of x. I b of x plus a, and a I can manipulate using this handle. Look, wow. Let me activate this and activate this. Okay, and you see when the a is positive, is the motion is vertical shift upward, and when the a is negative, is vertical shift downward. And you see how the only component que is affecting is the y, because the x stays the same. So when you adding one number outside the parentheses, the action is moving vertical because the y component change and the x component no stay the same. Okay, this is clear, super clear, right? Okay. However, let me do en B. B is horizontal. B. Let me see. Wait, what the hell? But wait. Let me restore A like a 0. So no vertical shift anymore. E only one transformation, no? So now I change B, and B is, look, ooh, when the B is positive, the motion is to the left. When the B is negative, the motion is to the right. And you can see how now changing, and the point changing the X component, is the first component. However, the second component no stay the same, is Y. So again, look, positive left, negative right. This is completely weird, right? Because in the parentheses you have plus B. Entonces, to memorize quickly is when you perform operations inside the parentheses, the action is completely inverted. Outside, no. Outside is the same. See, you adding over. But here, if you adding is left and you subtracting is right. Do you see or no?
Yes.
Well, let me restore here. No shift anymore. Unless transformation using stretch, compress, and reflection. Okay, so far no transformation. I multiplication by C. C1. Okay. C is positive and greater than 1. Look at the effect. The effect is, let me try to understand. It's vertical something, vertical transformation. However, you change the y component. And this y component is multiplied by the corresponding. Let me try to find one easy value to understand. Suppose 2. Okay, entonces at this point in the original function is 2,2 and 4,5. And the transformation is 2,4. Where come from 4? Well, 4 is the multiplication 2 times 2 because the factor that you introduce in the problem is 2. 2 times 2 and 2 times 5 is 10. This is typical vertical stretch. Vertical stretch. No shift, because shift is motion without deformation. In this case, no, we have deformation. It's a little bit different, no? The shape of this. However, if C is less than 1, suppose 0.5, 0.8, you see que es compressed. It's vertical compressed. Vertical compressed. You see, right? However, si C is negative, reflection. And the perfect reflection is when the C is -1. Let me show you, -1 is a perfect reflection. Okay, entonces, to understand perfect reflection, you multiply by -1, but you multiply the second component, que es the Y. The point is 2,2 in the original, this one. Now it's 2 comma negative 2 because y is affected by negative 1. And this is 4 comma 5 is 4 comma negative 5. Wow, super easy to understand by first reflection. Let me restore 1. The 1 means no transformation. No transformation. And let me try the last one, que es D. So you multiply now the number pero inside the parenthesis. Actually, when you multiply, it's division. It's completely opposite operation. Let's try. Suppose que D is greater than 1. Let me select one nice number to understand. 2. Hey, something wrong. No. Okay, something wrong. Okay. I did multiplication by 2, pero inside the parenthesis. Look, it's obvious que si you multiply inside the parenthesis, the component is affecting is x, no y. Y stays the same. Look, 2, 2, 5, 5. But you divide by 2, opposite operation inside the parenthesis. 2 divided by 2 is 1. 4 divided by 2 is 2. Entonces, if you, for example, select another number, suppose 4. Suppose 4. When you divide 2 divided by 4 is 1/2, 0.5. And 4 divided by 4 is 1. And the x in y component, sorry, stays the same. What is the name of this transformation? This is horizontal compress. And this happens when the D is greater than 1. On the other hand, when the D is less than 1, suppose like that, suppose 0.5. Then, well, you divide by 0.5. It's the same multiplication by 2. So you affect the x component. This is the original segment, the original function, 2,2, 4,5. Now 2 is transformed like a 4. Because you divide by 1/2. And when you divide by 1/2, you multiply by 2. And 4 divided by 1/2 is multiplied by 2. 4 times 2 is 8. Okay, what is the name of this transformation? Well, the name is horizontal stretch. Horizontal stretch. Now, if you go to the negative number as reflection, and the super perfect reflection is -1, but this reflection is with respect the y-axis. Basically, the action is you change the x component because the multiplication is inside the parenthesis, right? Now, by -1. Entonces, you multiply the first component, que es x, by -1 is -2, and 4 multiplied by -1 is -4, and the y component stays the same. Now it's more clear, guys, the transformation.
Yes.
Excellent, beautiful.
I have
Now, please, go ahead.
Oh, so you divide actually multiply when you multiply dividing.
I don't understand, miss. Speak slowly.
Like since you're dividing, so when you're dividing, you multiply.
Yeah. Okay. The super fantastic conclusion, when you are doing operation inside the parenthesis of the function notation, the actual action is completely opposite. When you multiply by 2, the action in x is divided by 2. Completely different situation happen when you multiply outside the parenthesis of the function notation. When you multiply outside the parenthesis in the function notation, the operation stays the same. Multiplication by 2, the y value multiplication by 2. Divided by 2, the y value divided by 2. Pero inside the parenthesis, no. Es interpreted. Es similar to the operation in the horizontal shift, que when it's plus, the motion is to the left because actually it's subtraction. However, you are doing plus inside the parenthesis. And when you have negative, it's addition, it's to the right. Make sense now?
Yes.
Oh, super. Okay, let's do in one more example. The last one of the transformation. Okay, let me switch into a whiteboard. Do you see whiteboard now? Okay, let me erase. Let me erase whiteboard. Okay. Okay, suppose that we have that graph. Okay, let me try. One image. No. Well, okay, don't worry. Let's do a graph by hand. Okay, suppose that graph. Okay. Suppose that graph. Okay. But that graph is given. You have a point here. Okay, 0,0. It's obvious that this is the x-axis. And this is the y-axis. We have here -1, -2. Okay, and we have here -1, 2, 3, and 4. This is -4. And we have another point here, that is here in -2, -4. If we have another point here, it's a -3 and -4. Here, -4. Okay, it's a point -4, 0. And our function look like that. It's a triangle. I call this function y equal h of x. This is h of x. Entonces, what is the question? The question is, well, doing the transformation, please try to do the graph of this function. Okay, it's y equal minus h in x plus 2. And you see two transformations, right? You see, so this, do the graph. The question says, do the graph of this. It's obvious that this, the shape is similar, no? You are doing something here. You are doing something here in order to find the graph of this. Okay, this is my goal, do the graph of this. And you see two transformations. The first transformation is, in my opinion, is this. Remember, the order of the operation determine the order of transformation, and you are doing backward from the innermost operation, que es x plus 2. So this operation is, so y equal h x plus 2. Es obvio que es a horizontal shift 2 unit to the left. So our graph now is 2 units to the left. Let me try to do it here, and the final answer I copy here, right? To the left is every component, for example, this is 0,0. Actually, point by point, this point is now located here. Let me use blue color, minus 2,0. Because you move to the left. You move to the left, the x component is decreasing by 2. 0 minus 2 is minus 2. And the y component, no, stay the same. This is now here, suppose, let me extend in this. This is a -6,0. At this point, que actually was Negative 4,0 is negative 6,0. So everything is moving to the left 2 units. Even this guy, when you move in this guy, is a negative 4 here. Negative 4, negative 4, comma, negative 4, no? Yeah. Entonces, our new function after the first transformation look like that. Well, not necessarily doing here. Everything doing in the same coordinate system, but using different color. And that's it. It's much better, right? So now, what is the last transformation? Well, the last transformation is obvious. Okay, it's reflection. Okay, it's this negative. Look. This negative indicates us reflection, pero es outside the parenthesis. Okay, be careful. Y is equal minus h x plus 2. Es obvio que es reflection. Pero reflection about x-axis. In other words, everything changing, pero in the y component, because this is outside, in the y component. Pero what is changing? Bueno, it's changing the second component point by point, no? Now, in this case, let me use in green color. This point stays the same, and this point stays the same. Why? Because it's 0, and 0 have no sign. To say it stays the same. However, this no. This now is a negative 4, comma, positive 4. Because you change this sign, this negative sign, change the sign of the second component. Guess why? And positive 4 is 1, 2, 3, 4 here. Okay, at that point now is this point. It actually is the point. Let me use in green color. Green color is, this point is, negative 4, comma, positive 4. And our final answer is the green part. Any question? Let me recap. The red one function is given graphically. No like another example is analytically. No, it's graphically. So you identification, you have to do the graph of the new one, and you identification what kind of transformation. The first transformation, according to the order of operation, is horizontal shift 2 units to the left because it's plus 2. So I transform it from the red graph to the blue graph, doing horizontal shift 2 units to the left. And finally, negative outside is reflection about the x-axis. I know. The only thing, point by point, is change the sign of the y component, que es the second component. At the point negative 4, comma, negative 4 is transformed to the point negative 4, comma, positive 4. And we connect it, and the rest of the point. So you take a reference point, because the other point obey the same transformation. Any question, guys? Do you follow me? Confusing, clear, horrible? Okay, in the review package, I promise. Can we continue doing transformation? Okay, the review package maybe is next week. Maybe not for sure, it's next week. May I erase the board?
Yes.
Okay. Okay, let's move on to the another section, que is a combination of the function. Well, let me try. Here, over there. Here. Combination of the function. Okay. Okay, so now we have two functions, no transformation anymore, no. We have two functions. And we combine, combination, I forgot here, combination. Oh, combination. You have two functions, and you combine. How? Using arithmetic operation or another operation that I want to explain after that. The first is one of the arithmetic operation: addition, subtraction, multiplication, and division. Suppose. What is the notation we use? Suppose that we have two functions, f of x plus g of x. Together is formed f plus g of x. Subtraction is the same. Suppose the notation is f minus g of x. Multiplication is f of x times g of x is f times g of x, and division is f of x divided by g of x, and the representation, symbolic representation, is f division g of x. Okay, in all the case, the domain of the new function is the intersection. So domain is equal domain of the function f intersection domain of the function g. Except in the division. The division is a little bit picky and introduce a new thing, a new condition, que is domain of f, of course, intersection domain of g. Intersection, remember, means common element, and you need to guarantee that g of x never is 0, because division by 0 is undefined. Okay, let's see example. Okay, in the example is easy because you need to determine the new function. Two functions is given. You need to determine the new function according to the operation that they want, and determine the domain. Always state is domain. Okay, suppose case given two functions. Suppose f of x is equal 1 over x plus 3, semicolon, and g is x over x plus 2. And to practice, we need to find everything: addition, subtraction, multiplication, and division. Let's start for addition. Suppose find in the test f plus g of x. Okay, I know that this is equivalent to say f of x plus g of x. And leave it like that. No, it's ugly like that. You need to condensing, no? You need to see condensing in only one common denominator, right? The LCD is obvious, que es both. Es x plus 3 times x plus 2. Because in the top part, when you condense in one common, least common denominator, and the first we have x plus 2 plus x times x plus 3, no? Do you follow me? Leave it like that. No. I need to distribute it. Combine like term, maybe. Okay, remove the parentheses. X plus 2 stays the same. However, this is x squared and 3x plus x squared plus 3x. Well, combine like term because we have here like term. Look, this is 1x, this is 3x together, a 4. And you organize in the elegant way in descending order of the degree, x squared plus 4x plus 2 divided by x plus 3. If you want, leave it like that. No necessary FOIL. Unnecessary FOIL. And this is the fantastic expression. que represent the addition to function. What I feel, no, the most important moment now. State is domain. To find the domain, you take the domain of f. The domain of f is, remember the restrictions. I repeat one more time. The supposition is all real number always except 3 restrictions. One restriction is when the denominator is 0. In this case, apply. Actually, do you put x plus 3? No, 0. Therefore, x no negative 3. So the domain you can represent like that. X such that x no 3. No negative 3, sorry. This is domain of this. And domain of G is similar. You take the expression in the denominator, no 0, and negative 2. So the bad guy is negative 2, the restrictions. Entonces x such that x no negative 2. Entonces, what is the domain of this expression? Well, this is the intersection, this and this together. Domain is domain of f plus g is all real numbers such that no 3, no negative 3, sorry, comma, or you write and, because it's the same, negative 2. There are many ways to write this answer. You can write like that, and other people prefer doing it that way. No negative 3, comma, negative 2. It's the same. Everyone understands. Another possibility, que is the possibility I prefer, is using the interval notation. And it is always any answer of the domain you express in interval notation. Let me show you interval notation. Okay, this is my famous all real number line. This is infinity positive. This is infinity negative. This is 0 in the middle. And we have two bad guys, que es negative 2 and negative 3. Negative 1, negative 2, and negative 3. So basically, we have a hole here. We have a hole here and here. A negative 2 and a negative 3. And the rest is okay. The rest is okay. So the rest is this. This. And this is okay. Now actually we have 3 intervals. You want to express the domain in the interval notation. Domain of f plus g is equal from negative infinity, comma negative 3, union from negative 3 to negative 2, union to negative 2, comma positive infinity. Okay, and this is equivalent. It's another way to represent this idea or this idea. Everyone follow me? Okay. Now subtraction. Subtraction is similar. Subtraction is similar. Subtraction is f minus g of x. Let's do it. Subtraction. Well, subtraction is 1 over x plus 3 minus x over x plus 2. So now, for finding the new expression, similar procedure, LCD, x plus 3 times x plus 2. This is x plus 2 minus x times x plus 3. Okay, let's do it. Now, x plus 3, x plus 2, x plus 2, minus x squared minus 3x. Yeah. Okay, now combine, lighter, and organize in descending order of the degree. This is minus x squared. Well, positive 1 and negative 3 together, and negative 2x plus 2, no? Yes. This is my new expression, que is the combination f and g together and the subtraction. And by the way, the domain is the same analysis, because domain, I don't care, the operation is the intersection domain of f and domain of g together, right? So no, I don't care. I don't care si es plus or minus or multiplication or division. Well, division is complicated because introduce a new restriction, but it's okay. Okay, now let's move on to the multiplication. It's relatively easy. It's no big deal. Multiplication is f times g of x. Well, it's multiplication. Multiplication who? 1 over x plus 3 times x over x plus 2. Well, if you want to condense it together in only one expression, you don't need to find the LCD. LCD is only when you add addition or subtraction. So 1 times x is x plus 3 times x plus 2. Wow, too easy. Multiplication, in my opinion, is the easier operation in fraction. And the domain is the same. Domain is the same. The same can we compute before in addition and subtraction. Same domain for this and same domain of this. And same domain, que by the way is this super fantastic expression. Okay, division. Well, division no. Division no. Because maybe division introduce additional, is the denominator not 0. So when you do a division, let's do a division. F division G of x is, let me just focus here, zoom in. This is 1 over x plus 3 divided by x over x plus 2. Well, entonces division, well, you copy the top, the first fraction, time and reciprocal of the second fraction. Okay, so the expression is x plus 2 divided by x times x plus 2. Okay, and this is the confusing part. Remember, the definition is domain, regardless if division, multiplication, or division, is the intersection. So I did our part. Stay the same situation, the same domain, but I can see a new undefined condition. Get this. Now you introduce, okay, 0 is also, okay, 0, no 0, illegal 0. That means in 0 we have another whole. Look here, another whole. In 0 for the division part. Entonces, the domain is not the same. Domain of f division G is from negative infinity, comma, negative 3, union, negative 3, comma, negative 2, union, negative 2, comma, 0, union, 0, comma, infinity. Okay, this is the domain, and the combination division is a little bit different because it introduces a new restriction. Okay. Maybe you say, well, professor, but no, what is the reason that you included 2? Si 2, we have a denominator now. Well, no. In the expression, yes, but here, si you introduce here negative 2, it's 0, and this denominator is undefined again. So that's easy. You respect the domain and the addition, subtraction, and multiplication is the same, pero you introduce a new condition que es determined by the zero in the denominator, right? Zero in the denominator. Okay, so far it's okay? Do you understand combination? Okay, entonces this is the only possibility of the combination? No. We have another very, very important combination que es composition. Composition. I can erase the board, right?
Yes.
Yes or no?
Yes.
Yes. Right? Okay. Composition. Let me explain composition in detail. Composition. Function composition. Function composition. Function composition. What is that? Well, this is, look, this is, you have two functions. You have the function f of x, and you have the function g of x. And you combine in this order, f composition g. So this zero look like zero, but actually it's not zero, indicate composition. I composite in this order. Oh, why not? You composite it in this order. Okay, the order is extremely important. Okay, what indicate that? Indicate, so this is equivalent. This is equivalent to express this. You have one function first, okay, g. So the function close to the domain element is g. That means that the first function que participate in the function is g. You evaluate g, you evaluate x into the g. And the result of this, you evaluate nf. Okay, this is another way to visualize composition. Let me explain. Yeah, I want to explain in detail right now. In this case, it's different. You evaluate nf first. And the result of this, you evaluate in g. Entonces, this look like a change rule. Suppose we have two functions. Example to understand this. Suppose we have two functions. The function f of x is the classical x squared. Everyone know. And the function g maybe is a reciprocal, 1 over x. You want to put the composition this. The composition, for example, in that order, f composition g of x is the interpretation of this is suppose the function you suppose in your mind is look like a box. And we have two functions. And this is the element in the input, get the x value. And get inside the first function, get g. This is g, and g is 1 over x. And the output of this box get inside the second function, que es f, que es the function x squared. And this is the total output. Total output, because this is the partial output. I suppose hypothetically, can you put one number, suppose 2. Reciprocal 1/2. And now square is 1 over 4. This is the idea. You understand this? Entonces I want to prove that this is completely non-commutative. Suppose que another student doing in this order, G composition F. Okay, we have this, but we interchange the boxes now. Now my first function is now F, que F is x squared. And my second is G now, que reciprocal. And And to compare the situation, I suppose can get in 3, not 2, because but 2 by coincidence is the same value, but 3 no. No, entonces now, okay, 2, sorry. Okay, let's do in 2. It's a coincidence que happen, pero no, okay. When you square it's 4, the output here. And when you reciprocal 1 and 4, wow, it's the same. Sometimes happen, que es the same, pero no. In general, no. In general, no. Let's do it for another example. Well, in this case, a coincidence. In this case, a coincidence. Pero in general, no. In general, but this was bad example. In general, no. O sea, F composition G of X no equal G composition F of X. No, this is a bad example because I select the reciprocal function, and the reciprocal function satisfies this condition because it's symmetric. But another example, let's do another example. Let's do another example. Suppose 2 couple function, f of x is equal x squared again, but g of x is maybe QB or absolute value. Why not? Absolute value. Entonces the composition f composition g of x is, I have no idea, is 2 boxes. Remember, change, connecting by this. The first function is g gets absolute value. G is the first one, plug it in. And the second is x squared. I select one value, x equal to 2. Actual value 2 is 2. And 2 squared is 4. This is the same stupid mistake. No mistake, because they are coincidence. See, you interchange this block. Suppose x squared here and absolute value here. And you introduce 2 again here. This is 4, and this is 4 because absolute value 4. Pero no. In general, no. In general, no. Keep in mind, in general, no. A more complicated function, no. So let's see example in which no. But you have the idea for the composition, no?
Yes.
Okay. Yes. Look, we have 2 functions, like complicated. So in complicated, I guarantee you, okay, we have no coincidence. The order is important, extremely important. You have 2 functions as given. I need to find the expression que represent f composition g of x. Question mark. This is the question. Okay. Entonces I realize que g is the first function. G is the innermost function. Therefore, g is this guy. Substitution. Here and here. So basically, in order to find the expression f composition g, the thing we are doing is replace x and f for the entire g into the f of x. Basically, it's 2x plus 3 squared plus 2x plus 3 plus 1. Do you understand what are you doing? Oh no. Do you understand what are you doing? Tell me. Do you understand what are you doing? Hey, what's going on? Do you understand the action?
No.
No, okay. You replace. Okay. This expression here into this. Okay, it's like f, que es the outermost function, you put G inside into the F. So you replace no X anymore in F. You replace by the expression 2X plus 3 que represent G. Make sense or no?
Yes.
And that's it, no? Well, the rest is just elementary kindergarten algebra. Put a more elegant way, and that's it. You fold here. 2x plus 3 times itself is 4x squared. First, outer, que is 6. Inner, que is 6 again. And last, que is 9. 3 times 3. Plus 2x plus 3 plus 1. Well, combine later. 4x squared and organize. Now, who is like this, and this? This is 12, 14x plus 13, no? Because 9, 12, 13. Okay. And this is expression that represent F composition G of X in this order. Curiosity. Let's do it in different order. Same function, but in different order. Suppose G composition F of X. Okay, so the supposition now is que F is the first function. Okay, F is that function. Let me use in blue color. This is F. This is my first. Look here. I'm plugging it into the X of the second. Now you replace the X of the G, because G in this order represent the outermost function. Find the entire expression of F, que is the innermost function. Okay. So now the action is 2 times something, 2 times x squared plus x plus 1. Plus 3. Do you understand the thing I am doing or no? So you take the entire F, I enclose in the blue color, I replace by the X and G. And that's it? No. I distribute it 2x squared plus 2x plus 2 plus 3. That now the conclusion is G composition F of X is 2x squared plus 2x plus 5. Boom, final answer. And you see that this expression and this expression are completely different. This is the thing I try to explain. Is that normally in general, the composition is completely different. Completely different. You cannot interchange G and F in the composition. In addition, yes. In subtraction, no. In multiplication, yes. It's commutative. In division, no. Y en composition, no. In general, no. Some particular case, yes. But in general, no. Do you follow me?
Yes.
Let me try to do one more example of the composition. That's it. And that's it. May I erase the board?
Yes.
Okay. Okay, guys, look, it's given two functions. The first one is 4 over x minus 1, semicolon, and G is x over x plus 2. And what is my goal? Well, my goal is find the composition F composition G of X. Okay, so far, that's the idea. Okay, let's do it. Entonces, I realize que G is my closed function. So the expression for the G I replace for here. Therefore, the thing is f of x is equal 4 over. No x anymore. No. I copy x over x plus 3. You replace the x of the function f, que es the outermost function, for the entire g function here. Minus 1. Something like that. Do you see that or no?
Yes.
And the rest is algebra. Okay, I want to copy. Well, no, copy. Copy, no. Well, you copy. Okay, now you find the least common denominator because I want to condense in this. Okay, look. This is 4 over least common denominator is x plus 3. You have x minus x plus 3. The distributive now is 4 over x minus 3 divided by x plus 3. And this is cancelled. Look, positive x and negative x, and stay alive. Well, I copy 4 over 1 time, flip that, is x plus 3 over negative 3. So actually is negative 4 over 3 parenthesis x plus 3. You can leave it like that. Okay, this represents the function f composition g of x in this order. Okay. And that's it, no? No, because I want to investigate domain. Again, this is the most complicated part. So the domain, what is the formula? The formula is domain of f composition g is equal. This is the formula. It's domain of g. Why? Because domain of g is the first function, and this is the most important. Remember in the sketch of the block, g is the first and f is the second. No? Entonces, if the number that you want to plug in here don't belong to the domain of g, is undefined. So the domain of g is fundamental. It's the most important thing. Intersection, domain of new expression. Similar to division, no? But in this case, new expression. Who is new expression? New expression is this. The expression that you find when you condense in this and this together in only one, no? Entonces, what is the domain of G? When I come back to G, domain of G is all real number except negative 3. How do you know that negative 3 is a bad guy? Because you take the denominator, no 0, it's obvious that x, no negative 3. And what is the domain of the new expression? Well, the new expression is a linear expression. It's a line. We have no division. We have no square root. The domain is all real number. The domain of this, the new expression, domain of new expression is all real number. Now intersection. To intersect in both. Well, to intersect in both, let me show you. This is my famous all real number line. Okay. Infinity positive, infinity negative. Okay. In this case, we have one whole, que es el negative 3. Negative 1, negative 2, negative 3. Here we have whole and negative 3. And for this, we have no restriction or real number. Therefore, the only bad guy we have in the game, in this game, is negative 3. Entonces, the domain is this interval and this interval, two intervals. Therefore, domain of the function f composition g is equal from negative infinity, comma negative 3 union negative 3, comma infinity. Super fantastic. We finished for now, guys. Next class, we finished that part. So we are doing the same example but backward. No F composition G, sino G composition F, and another example. And we start review package. Okay? Okay. Any question? The thing that you should do is continue doing the homework. Homework 1, 2, and 3. Any question that you have about the homework, please communicate with me by email or stop recording.